Hello.
Hello, good morning, sir.
Yeah, good morning. So I hope today some student will join.
Okay.
No, that is not okay. I hope because I am giving my time and they are not joining. And today will be the last session, right?
Yes, sir.
Okay. Okay, fine. And then I'll wait. So no one joined. How long do we have to wait? 15 minutes?
15 minutes, yes, sir.
Okay. Okay, fine. Thank you.
Hello.
Hello.
Hello, sir. We have received one query through the Google form. I have shared it in chat box, sir.
Hold on a second. You send it in a chat box, right?
Yes.
What is the question?
Yes. Can you explain more about parallel beam illumination?
Parallel beam illumination. Can anyone give me the notepad kind of thing so I can go and draw something and explain it to him? Whoever is there from NPTL, it will be easier for me. Hold on a second. Okay. Can you see my screen?
Yes, sir, we can see.
Okay, let me go to here. Okay. Okay. So if you remember how electron beams are coming and giving us an image, so if you just consider that, okay, there are, do you remember the lens system, how the electron beam are converged and diverged after the accelerating stack? If I just ask you what kind of lens system is there, do you recall what kind of lens system do we have there? Hello? Gaurav, you are muted. Do you want to say anything or I'll just continue? Okay, fine. So here, if you look at this, this is the, if you have the accelerating stack here, so electron beams are coming and it just diverge and then converge by the C1 lens system, that is called condenser lens 1. And first C1 lens, it will converge and this will be the crossover point. This is the first crossover point if you just consider. So this is our first crossover point, right? So this first crossover point, this is called the spot size. And the second one is the C2 lens current, that C2 lens we are using. And then we are getting, this is the intensity we are considering. Now the parallel electron beam, we said that okay, so after C2 lens, you have the upper objective lens and the lower objective lens. If I just draw it like that, this should be the upper objective lens. So this will be the upper objective lens and then your lower objective lens, it will come here. So this will be your lower objective lens. Okay. So now your sample, it will go somewhere here. So your sample will stay somewhere here where electron beam will go. But if you look at this particular diagram, you can feel it that the electron beams are not parallel. If when we are talking about electron beams are parallel, electron beam should go like that. So these two lines are called the parallel line, right? These two lines. But this is not the parallel line. Now, if I have to make the electron beam parallel, how I can do this one? So this is my first step where I have the C1 lens. C1 lens current, electron beam will converge in particular one point. Now, if we are using a stronger electric current, the crossover point will go up in this particular direction for the stronger size, stronger even lens current. And now, if my sample head here, what I want also about point and in particular I have, and this is my lower addition is the upper objects. Can you guys hear me? Hello?
Yes, sir, we can hear you.
Okay. From student side, I cannot see any response. That's why it is very... Okay, fine. So you can see that diagram, right?
No, sir.
You cannot see. So previously you can see my diagram.
Yeah, yes, sir.
Okay, hold on a second. Okay, can you see it now?
Yes, sir.
Okay, fine. So here what we are trying to do, we are just using this one, that electron beam, we are making the crossover point using the C2 lens in such a way that electron beam will just converge above the sample. When the electron beam will converge just above the sample, if we just use this particular area and enlarge it here, what you can see, that electron beam is just converge above the sample. So this is the converging point and this is my sample. And now when the electron will come out, so this upper magnetic lens, this is my upper objective lens. And this is my lower objective lens. This upper objective lens current we are using in such a way that electron beam, it will come out and go like that as a parallel vision. So it will be a very small portion, it will be exposed and electron beam will be parallel like that. The other way we can make that electron beam parallel, if you just consider that this is the crossover point, we have something like that. This is the C1 lens current. C1 lens, it will converge C2 lens current will keep it in such a way, it will not converge like that. So it will not go and converge in this particular point. We are making a very under focused lens current. So you can see if your sample is there, electron beam is almost parallel, but it is going to expose your entire sample. That is the main reason we prefer to convert the electron beam just above the sample, and then you do the imaging and using the objective lens current to make the electron beam parallel. Is it clear? Hello? Hello? Can you guys hear me?
Yes, sir, we can hear you.
Okay, so there is no response from the other side. That's why I'm not very sure
He said
whatever
yes, sir.
huh,
He said yes in chat box.
is in the chat box. Okay. Okay, so anything else?
Hello, sir. We have received one more question on YouTube.
Say again.
We have received one more question, sir.
So that you wrote, right?
Yes, sir. That one.
During the practical session, do I just explain it verbally or do I just write the answer here?
Anything is okay, sir.
Okay, I can answer it verbally. It will be easier for me.
No.
Okay, so this is a very normal thing when you look at your ethane container in your practical session. So in practical session, what you are doing initially, you have a container where you are adding liquid nitrogen, and there is a brush container where you are adding the liquid gaseous ethane. So initially you have the liquid nitrogen all over. So when there is a liquid nitrogen, all this liquid nitrogen vapor, it will come. So there is a no way that moisture or water can stay there. So when you are adding ethane, so liquid nitrogen temperature, if you consider, temperature will be minus 196. And then you are adding liquid ethane. So you are adding the ethane, gaseous ethane, and gaseous ethane will convert to the liquid ethane. So temperature, when it will form the liquid ethane, the temperature will be minus 42 only. But for a long time, when it will go, so some point the temperature, it will go down to minus 180, minus 184. When it will reach to minus 180 or minus 184, it will basically the freezing temperature for the ethane. And then ethane will start freezing. And you can see that frozen small white ethane ice. So whatever you can see it in there, in the container, near the ethane container, those are definitely, it is ice, but it is not formed by water molecule. It formed the from the ethane. So those are, you can call that ethane ice. Sometimes those ethane ice are good because whenever you freeze your sample, there is no thermometer you can attach with the container, brass container, and measure the temperature. So whenever you will freeze the sample, it is recommended your ethane temperature should be minus 180, minus 180, near the minus 180. So if it is near that, your freezing will be good. Otherwise, if temperature is only minus 100 or minus 100, 120, you can see a lot of crystalline ice. So if you can see the frozen ethane here, there, you can imagine your temperature of that ethane container is minus 184, and your ethane temperature, that liquid ethane temperature, is also very close to minus 184, or maybe near around minus 180. So it is the right time to freeze your sample. Okay, so those white ice are the ethane ice, not the ice formed by moisture or water. I hope I cleared your doubts.
He said, okay, sir. Thank you.
Anything else? I should wait a little bit, right?
We will wait for 2-3 minutes, sir. If there are no questions, we can end this session.
Okay, okay. You let me know. I'm just keeping it mute.
Okay, sir.
I have one question. Can I ask that question?
Yes, sir.
So I have a feeling all these YouTube videos are available to all over world. Anyone can see it.
Yes, sir.
They register for the NPTEL course or not, it doesn't matter.
Yeah,
Am I correct?
you are correct, sir.
But that should not be the case, isn't it?
The enroller students can also watch, sir.
No, no. Enrollment student can watch, but whoever is not enrolled, that person should not watch. That is my point. Because I'm sharing my own experience. When I started my course, you can consider this my course is very specialized course, and in India very few can teach this course. And now I know that when I started this course in ISC, some of the people they gathered all this my PPT from my students, and they started their own course in their own institute. And they are basically from ISAR or someone from the IITs also. My point is that why do I, when I spend so much time to prepare those things, why do I give all these things to other people? Who can answer this question?
Okay, sir. This thing I will check with the IITM people. And
So,
I'll
so
get back
you
to that,
just
sir.
you just tell. So look, my point is. So in this particular case, I can also generate a YouTube video and upload those things in YouTube. Right. This is not a big deal for nowadays for anyone. Then why it is required for NPTEL and others? My point is that only my videos will be only accessible to those students who register for the course, not for all the people. Because then they can get that idea and they can start this kind of course in their institute. And I don't want that. I know those people how much they are capable, and I don't want to do this thing. And
Okay, sir. I will check with the IITM office and I'll get back to you, sir.
please. Okay.
Okay, sir.
Your name?
Bharat, sir.
Bharat.
Hmm.
Thank you, Bharat.
Thank you, sir. I think we can end this session now, sir.